Have you ever tried walking under the scorching heat of the sun?
How about placing an ice to your hand?
Or boil water using a kettle.
The situations given are all great examples for the topic that we will be discussing in this video. Let us all together explore, understand, and discover the wonders of heat and temperature.
Hello there, I'm Eva, and I'll be presenting you first our learning objectives. First is to define what is heat and temperature. Second is to differentiate heat from temperature. Third is to demonstrate and show examples on how does it work. And the last one is to provide some real-life examples of it. To officially start, let me call on the first presenter, Mr. Noel.
Thank you, Miss Eva. Hello, everyone. Again, I am Noel, and let's discuss heat. There are lots of forms of energy, and heat is under the umbrella of thermal energy. Heat refers to the overall energy of a molecular motion. And since we are talking about molecular motion, kinetic energy has an important role in understanding this concept. It is a common knowledge that every phase of matter has these so-called molecules that reacts to heat. For instance, when you turn on your stove to boil water in a kettle, water, after a few minutes of waiting, would show signs of excitement. What are these excitements imply? These excitements happen because of the heat coming from the stove is transferred to the water. Thus, the water itself attained the heat as well, and the motion of the water molecules is increased. It can be obviously seen that a boiling water moves up and down, back and forth. This is a prime example of heat transfer. It is safe to say that heat flows from a hot object to a cool object. Heat transfer is a transfer of kinetic energy, which should eventually alter the temperature of another object. Another example is a cup of coffee. When we are holding a cup of coffee, we can feel the heat of it on our hands, simply because heat is transferred from the coffee to our hands. As this transfer continues, it will eventually reach a point where both objects, in our case, my hands and the cup, are in the same temperature, thus achieving the thermal equilibrium. There are three main ways heat can be transferred. First is conduction. Conduction is transfer of heat through a material by direct contact. Using the example earlier, the heat coming from the stove burner conducts its heat to the metal kettle pot, as these kettle pots serve as our conductor before transferring its heat to the cooler object, the water. This is where another way of heat transfer happens. Convection. Convection happens when a fluid like air or water is heated. In our case, the area closest to the heated kettle pot will be firstly getting the heat. The molecules will then expand, becomes less dense and rises, while the colder molecules will be much denser and replaces them below, until such cycle repeats over and over again until heat is generally transferred. Last way of heat transfer is radiation, which is a process that involves heat waves. Heat waves are released that may be reflected, absorbed, or transmitted through a colder body. A good example is by standing near a bonfire. The heat waves coming from the flame will be usually absorbed by your body, especially when the environment is initially cold. Heat is represented by the letter Q, the process variable. It is mainly measured using a calorimeter, using the units of calorie or joules. Now that we all understood heat, let's proceed with heat's partner in crime, temperature, with Miss Leizl reporting.
Thank you, Noel. That was such a meaningful discussion presented by you. And now let's formally start and discuss temperature. We all have heard the word temperature. Most commonly, when we are experiencing fever, we immediately feel that our body temperature is gradually rising. Temperature, in simpler terms, is a measurement of how hot or cold an object is. It is the average energy of molecular motion and the measure of the intensity of heat. Unlike heat, which involves heat transfer, temperature does not involve in such. Rather, it just usually goes up and down depending on the environment. In other terms, temperature value rises when heated and falls down when cooled. The proper device to measure temperature is none other than the thermometer. Thermometers are great devices to measure the temperature levels of all three phases of matter. The first picture is mercury in a glass or a mercury thermometer. The second one is a digital thermometer we usually found in our homes. These devices work with the use of heat that will be in contact to it. Mercury molecules having a high coefficient of expansion would immediately spike up until it is in thermal equilibrium with whatever environment it has been in contact with. The units that are commonly used for measuring temperature is Kelvin, Celsius, and Fahrenheit. It is also important to take note that all three phases of matter, solid, liquid, and gas, expands with higher temperature. Solids, when become extremely hot, would break or melt down. Liquids having high temperature usually evaporates and becomes water vapor. Gas, on the other hand, when heated, usually just increases the speed of its molecules. In cases when gas is contained and in a fixed volume, increasing its temperature results in an increase of its pressure. Were you able to comprehend the definitions and concepts thoroughly presented? If you did, let's enforce that learning more with a side-to-side comparison and the difference of heat and temperature. For this, Ms. Eva will guide and show you the difference of heat and temperature.
Thank you, Leizl. Hi everyone. Again, I'm Eva and I'll be showing you the differences between the two terms mentioned a while ago. So what makes the heat different from temperature? Well, heat is a transfer of thermal energy from a hotter object to a cooler object. An ice cube, for example. We all know that when we get an ice out from the fridge, it will begin to melt. That's because the heat from its surrounding is being transferred to the ice. And from there, there's a heat energy. While temperature is a measurement of how hot or cold an object is. For example, you might notice that today's temperature is so low, which explains why it's so cold today. Heat is a form of energy and is the overall energy of a molecular motion, while temperature is a measure of energy and is the average energy of a molecular motion. Heat involves a transfer of kinetic energy from a hotter object to a cooler object, while temperature simply rises and cools down when cooled. Just like when we're measuring our body temperature. Our body temperature rises when we have a high fever, and it also cools down when our body cools down. The SI units for heat are joules and calorie, while Kelvin, Celsius, and Fahrenheit for temperature. Heat is measured through calorimeter, while temperature is measured using thermometer. Were you able to understand the comparison I've presented? If you finally get a grasp on it, let's take a look at some real-life examples of work done by both heat and temperature. With that, Ms. Charissa will be presenting.
Thank you, Eva. And to keep the knowledge retained, I'll be presenting some real-life examples of heat and temperature and how it works. So the heating of the earth by the sun is an example of heat transfer using radiation. So temperature levels of our planet will then slowly rise. Second example is the transfer of thermal energy to the roofs of our houses. So we can measure the temperature of the heated roof using a thermometer. Another example is when we're having a cold cup of water. The heat energy of our hands will transfer to the cup until the cup is as warm as your hands. So, ironing of clothes is a great example of heat transfer. The high temperature of the iron containing high levels of heat waves to the clothing material, which would straighten the curls of a cloth due to awakening of a chemical bonds formed between adjacent polymer strands in clothes fibers. In your room, heat transfer works through convection. It has been mentioned that hotter air rises while the colder air sinks. This phenomena happens when colder air is released from an air conditioner and the hotter air that is naturally inside your room will immediately rise. The cycle continues until it reaches the thermal equilibrium. So, I believe that you have learned something today and congratulations. So I'll see you the next time.
Let's always remember the fundamentals of heat and temperature, its difference, and how does it work together.
As we dive into the complex world of thermodynamics, we will be always here to teach and guide you in explaining these difficult terms a lot more simpler.
This is the Group 4 presenting. Remember, curiosity gives space for your mind to explore. Stay curious, people!